Okay, today we will see what are the types of induction machine. So according to the rotor, we can classify induction machine into two, that is squirrel cage and phase wound. So let us start from squirrel cage 1 and see how it looks like. So here we have a terminal box, as you see it here, which is used for connecting the terminal or the source to the machine. And here we have a fan, which is used for ventilating the machine or in order to reduce heat. And here we have a ball bearing, which is used to rotate the bearing inside the machine. And here we have a bearing, which is used to rotate the rotor or the shaft inside the machine. And we have a ventilation shield, a ventilator shield, which is used to protect the ventilator from damage. And here we have a rotor core, which is used for electromechanical energy conversion. And here we have a stator core, which is used for producing the main pole. And here we have a frame, which is used for mechanical protection, and basement used for attaching the motor to other mechanical devices. Here we have a shaft, which is used to rotate the rotor conductor inside the machine. And then we will see the parts practically here. So as I mentioned there, we have a rotor, that means squirrel cage 1. According to the rotor, we classify induction machine as a squirrel cage 1 and a phase wound. Squirrel cage 1 and a phase wound. So when we see here we have a terminal box. So this terminal box is used to connect the source to the machine. And then we have a fan here. This fan is used to reduce heat, or used to ventilate the machine to reduce heat loss. And the other one is we have a bearing. You see this one, the one that used to rotate the shaft inside the machine. And we have a rotor here. So the rotor is used for electromechanical energy conversion. So here we have the stator. This one is the main pole with the main winding. So together they are used for producing the main magnetic flux. And then this, the mechanical part, we call it a frame. So it is used for protecting the machine from damage. And then here we have a ventilation shield. This ventilation shield is used to protect the ventilator from damage. And this one is a basement, used to attach the machine to the other mechanical device. So when we see independently, this one is the rotor. Say for the rotor, for a squirrel cage 1, we put a short circuit. We put the iron bar inside and short circuit by using a short circuit device here, the aluminum rings. And we slightly skewed the rotor slots. Why? Because in order to reduce the magnetic hump and the interlocking tendency inside the machine, we slightly skewed the rotor for a squirrel cage 1. So this one, we call it a shaft. That is used to rotate the rotor bar or the rotor material inside the machine. And this one, we call it a bearing, used to rotate the shaft inside the machine. So here we have a ventilator, and here the end cap. And after the ventilator, we have a ventilator shield, which is used to protect the ventilator from damage. And when we see the stator of a machine, because we classify induction machine into two, squirrel cage 1 and phase wound. And the parts we classify into two also, the stator and also the rotor. So when we see the stator, we have a stator conductor and a slot. So together they are used for producing the main magnetic flux. So here it's removed. We have the terminal box, and then this is the basement, and this is the frame that we used for protecting the machine from damage. And when we see the other types of squirrel cage, other types of induction machine is a phase wound one. So when we see the phase wound here we have a slip ring. That means before we saw that the squirrel cage is short circuited on both sides, but when we come to phase wound, the other side of the rotor is connected to the slip rings. So here the slip rings are connected with the brush so that they can take current out or into the machine. So this one is phase wound type, but the other parts are the same. The difference is the slip rings. But at normal running condition, the phase wound acts like a squirrel-cage one. That means if we short these slip rings together by using short circuiting device, that means on this side is short and the other side is also start connected. So both sides are shorted. That means it acts like a squirrel-cage one. So under normal running condition, the phase wound acts like a squirrel-cage induction machine. But because of we have slip rings, we can add additional resistance. As you see it here, it's shorted on both sides, so there is no way to add additional resistance here. But here we can add additional resistance so that we can decrease the starting current, which reaches to 5 to 8 times of the rated current of the machine. Also, we can change the speed torque characteristics, for a machine. So because of we have those advantages, we can use phase wound. But because of the cost, when we see here, we have a cost for slip ring, brushes, so the cost is more than the squirrel-cage one. So the squirrel-cage is rigid in construction, so that most of the industries use squirrel-cage one than phase wound, because we have additional cost and we have also losses due to the phase wound. So because of that, we choose squirrel-cage one mostly than a phase wound one. So as you see it here, there is no slip ring here, but there is a slip ring here. So if there is a slip ring, there is a loss, and the efficiency for a squirrel-cage is higher because there is no loss due to brush contact with the slip rings. So the efficiency is more, and it has cheaper and rigid in construction. As you see it here, it's cheaper because there is no slip ring, there is no brush here, so that because of there is no brush and slip ring, the squirrel-cage is cheaper and rigid in construction, and also it has a better space factor. As you see it here, there is a better space factor than this one, because there is a slip ring here and the brushes, so the space is occupied by those things. But here there is no brush and slip ring, so that there is a better space factor here. And also it has bearing rings and large space factor for fans, and the cooling condition is better than the phase wound one. So it's smaller rotor overhang. As you see it here, there is a smaller rotor overhang, but here we have a bigger rotor overhang compared with a squirrel-cage one. So because of those advantages, we use mostly a squirrel-cage one than a phase wound one. But the other disadvantage for a squirrel-cage is we can't add additional resistance to the rotor because of there is no slip rings and brushes here. So if there is no slip ring, so there is no way to add additional resistance. If there is no way to add additional resistance, that means it's not possible to reduce the starting current by using additional resistance connected to the rotor, even if there are other means to reduce the starting current. And also we can't increase the starting torque by using the rotor resistance. And also we can't vary the speed torque characteristics for a squirrel-cage one. But the other advantages are more than the phase wound one. So because of that, mostly we use squirrel-cage than phase wound. So these are the things that we see from the induction machine.